Hello students, welcome to your mathematics class. Today in this video, you will learn about the chapter integers, and my discussion topic in this video is division of integers and some properties of division of integers. We know that division is the inverse operation of multiplication. For example, if we multiply 7 by 8, we get their product as 56. Now, if we divide 56 by 7, we get the quotient as 8. Here 56 is called the dividend, 7 is called the divisor, and 8 is called the quotient. So also this division, we can also in this division we can say that here 7 is contained in 56 8 times. So here 7 is contained in 56 8 times. Now if we write 56 division 8, then we get the question as 7. So in this case, we can write here 8 is contained in 56. How many times? 7 times. So from this example, we can see that for every multiplication statement, we can write two division statements. This is one statement and this is another one. So we can say that if a and b not equal to 0 are any two integers, then dividing a by b is same as finding an integer c, which when multiplied by b gives a. Thus a division b equal to c implies b multiplied by c is equal to a. Now you have learned that how to divide a natural number by another natural number. Now let us see the rules for division of integers. When we divide an integer by another integer, if the dividend is completely divisible by the divisor, then we get the remainder 0. So in that case, the sign of the quotient, whatever quotient we will get, the sign of the quotient will depend on the sign of the dividend and the divisor. For example, if the dividend and the divisor both have the same sign, then the quotient is always positive. If we divide, for example, if we divide a positive integer by a positive integer or a negative integer by a negative integer, so in that case what we will do? First, we will divide the integers without their signs, and then we give a positive sign to the quotient so obtained. That is, for example, if we consider a plus a as the dividend and plus b as the divisor, then plus a division plus b will be equal to plus c, which is the quotient. Similarly, if both are negative, that means when the dividend is negative minus a, divisor is negative minus b, then minus a division minus b will equal to, again we get the quotient as here positive. So in this case, if the dividend and divisor both are of the same sign, that means either both of them are positive or both of them are negative, so in that case the quotient will be always positive. For example, if we divide 132 by 11, so here both the integers are positive, so the quotient will be also positive. So let us find out the quotient first. So both are natural numbers. We know how to divide a natural number by another natural number. So in that way we will divide by using the division method, that is long division method. So here 11 ones are 11. We subtract 11 from 13. So here we get 2. Then we bring down the next digit, that is 2. So 11 twos are 22. So if we subtract them, we get the remainder 0. So we stop our division process here. So here we are getting the quotient as 12. As both are positive integers, so it's their quotient will be also positive. In the second case, minus 36 division minus 12. So first we will divide the two integers by taking the integers without their sign. So considering the integers without their sign, that means 30 minus 36 becomes 36 and this minus 12 becomes 12. After division, whatever result we will get, before that we put the positive sign because both are negative in sign. So the result of the question will be a positive integer. So we know that 12 threes are 36. So here we will get the question 3 and the sign of the question will be here also positive. So in this case we can see that both the cases we are getting the positive integers. The questions are positive when both the integers are in same sign, that is the dividend and the divisor. Now let us consider the case when the dividend and the divisor, when both are opposite in signs. So if the dividend and the divisor both have the opposite signs, then the quotient is here negative. That means when we divide a positive integer by a negative integer or a negative integer by a positive integer, in that case first we divide the integers without their signs and then give a negative sign to the quotient so obtained. So if minus a is the dividend and plus b is the divisor, so both are in opposite signs. So their quotient will be here minus c, that is negative. Again, if plus a is the dividend and minus b is the divisor, then their quotient will be also minus c, that is the negative. For example, if we divide minus 150 by 25, here minus 150 is the dividend and 25 is the divisor. So in this case, first we divide the integers without their signs. So first we divide 150 by 25 and then we put the negative sign to their quotient. So here if you divide 150 by 25, it will be completely divisible. So we get the quotient here 6. So we get the answer here minus 6 as the quotient. Now consider the second example, 65 division minus 13. Here divisor is the negative. So first again we divide them without their sign. So 65 division 13 and we put the sign negative to their quotient. So here we will get minus 5 because if we divide 65 by 13 we get the quotient 5. So we get here the result as minus 5. So in this way we can divide the two integers, either they are of same sign or they are in opposite signs. Now let us see some properties of division of integers. The first property is here closure property. If a and b not equal to 0 are any two integers, then a division b may or may not be an integer. For example, if we divide 12 by minus 3, we get the quotient here as minus 4, which is an integer. But if we divide 7 by 3, we get the quotient here as 7 by 3. We are not getting an integer here, so which is not an integer. So in both the cases we are getting two different results. In the first case we are getting an integer, in the second case we are not getting an integer. So we can say that integers are not closed under division. Now let us consider the commutative property. If a and b are any two non-zero integers, then in general a division b is not equal to b division a, except a equal to b. For example, if we consider a equal to 15 and b equal to minus 3, then 15 division minus 3 will give minus 5. On the other hand, minus 3 division 15 will give minus of 1 by 5. So here we can see that minus 5 is not equal to minus 1 by 5. So that means division of integers is not commutative. But if we consider both a and b equal, then in case of a, if we write a equal to, suppose a equal to 5, then 5 division 5 will give 1. On the other hand, 5 division 5 will give 1. So both we are getting the same result. That means a division b equal to b division a. So when both the values of a and b are equal, that time only a division b is equal to b division a. Otherwise, in general, division of integers is not commutative. Now, let us consider another important property, that is associative property. If a, b and c are any three non-zero integers, then in general a division under bracket b division c is not equal to under bracket a division b division c unless c equal to 1. Let us see one example. If we consider a equal to -8, b equal to 4 and c equal to -2, then what happened? If we put left hand side is equal to a means here -8, then we put division sign, then b means 4, division -2. So in this case, we will see that -8 division. Now 4 division -2, we will get -2. So again -8 division -2 will give positive integer, that is we will get here 4. Now on the other side, that is on the right hand side, if we put the value, that means a division b, if you put -8 division 4, then division -2. So here we will get -2 division -2. So that will give only 1. So from this to result, we can see that 4 is not equal to 1. That means this result is not equal. Means this a division under bracket b division c is not equal to under bracket a division b division c. Thus we can say that division of integers is not associative. So division of integers is not associative. Now let us see another important property. If a, b, c are any three non-zero integers, and if a is greater than b, then a division c is greater than b division c if c is positive. For example, if we consider a is equal to -5 and b is equal to -10, then here -5 is greater than -10, and if we consider c is equal to 5, which is a positive integer, so if we divide -5 by 5, we get here -1, and if we divide -10 by 5, we get here -2. So here we can see that -1 is greater than -2, which is true as this condition is already given, that if a is greater than b, then a division c is greater than b division c if c is positive. Now let us consider the case if a is greater than b but c is negative, then what will happen? In this case, if we consider a equal to -5, b equal to -10, and suppose c is equal to -5, that means c is here negative, then we get here -5 division -5 is equal to, we get here +1, but if we consider -10 division -5, we get here +2. So in that case, we can find that 1 is less than 2. So here if a is greater than b and if c is less than 0, then a division c is less than b division c. So this sign will reverse. Now for any non-zero integer a, we can say that a division 1 equal to a division -1 equal to -a division a equal to 1, 0 division a equal to 0, but a division 0 is not defined. Now let us do one example. Find x if x division -18 is equal to -5. So this we can write it as x by -18 is equal to -5. So this means x can be written as x equal to -5 multiplied by -18. Both are negative sign, so their product will be positive. So this implies x is equal to 90. So the value of x is here 90. Now let us do another example. Find the two pairs of integers a comma b such that a division b is equal to -3. So this we can write it as a division b means a by b is equal to -3, which implies a is equal to -3 multiplied by b. Now if we consider b is equal to suppose 2, then what we will get? Then a becomes -3 multiplied by +2 is equal to -6. So when a is equal to -6, b is equal to 2. So we get one pair as -6, 2. If we divide them, we get the quotient as -3. So this one pair we get. Next, if we consider again in this equation, if we put b is equal to suppose 3. So if we put b is equal to 3, then what will happen? Then a will be equal to minus 3 multiplied by 3. That becomes minus 9. So another pair of integers we get minus 9 comma 3. So if we divide them, we get the quotient as minus 3. So in this case, in this way, we can find many pair of integers. When we divide them, we get the quotient as minus 3. So in this way, you can try some questions which is given in your book. I hope all of you understood whatever discussed today in this video. So thank you all of you and have a nice day.